Okay, welcome to this video. We'll be having a look at a practice paper for the Paper 2 Maths exam, which is a calculator-based paper. So we are going to be using a calculator throughout this paper, and as always, the links are in the description if you'd like to download it. If you've got it downloaded, you can scan the QR code on the front to get back to this video at any point. So, starting with question 1. It says write down the value of the 3 in the number 4,376. As you speak it, we kind of have the value there. So the 3 has the value 300. So we go 300 would be our answer. That is the value of the 3. For question 2, it says to write 3% as a fraction. Now, any percentage can be written as a fraction by putting it over 100. You can actually type this into your calculator as well. You can press 3 and your percentage button, and it'll actually bring it up as a fraction. But it's nice and easy. We just put the percentage, which is 3, over 100, as percent means per 100. So there we go. 3% is 3 over 100. For our next question, it says to change 4,000 grams into kilograms. So you need to know your conversion here, and that is that there are 1,000 grams in every kilogram. So we would need to divide this by 1,000, or you might just be aware there that if there's 1,000 grams in 1 kilogram, well, 4,000 grams will be 4 kilograms. But there we go, you could divide by 1,000 to convert from grams to kilograms. For question 4, we have an equation to solve. It looks more complex than it actually is. It says to solve 3 is equal to 12 over something. Well, essentially all this is saying is, well, 3 is equal to 12 divided by, and then it wants us to know what number. So what do you divide 12 by to get 3? Well, hopefully you know that the answer to that is 4. You divide 12 by 4 to get 3. However, if you're not sure, you could swap them around and think, well, what's 12 divided by 3? And the answer for that is 4. So different ways that you can look at it, but if you have these little equations early on in an exam paper, try not to overcomplicate them too much. It is just asking you to find that missing number. Okay, question 5. Writing these numbers in order of size, so we have negative numbers here. So we're looking for the largest negative to start with. So the largest negative is over here, negative 20. So that'd have to be our first one, negative 20. And then we're looking for our next largest negative, so negative 16. And it's always a good idea to sort of tick them off as you go, just to make sure we don't miss any. We then have negative 4. We then have that 0 there, where we start to change now from negatives into positives. And we only have the one positive number, which is 8. So 8 would go at the end. And there we go, that's writing them in order of size, and that's starting with the smallest number. On to the next one. So here we have a percentage of an amount. It's asking us to work out 70% of 90. Now ordinarily, I would just write down what 10% is and times it by 7. However, we are using a calculator. So if we are using a calculator, typically whatever percentage I have, I'll go down to 1%. So in this case, to get down to 1%, we are going to want to divide by 100. So 90 divided by 100 will get us 1. And we can just type that in on the calculator. It comes out as 0.9. So 1% is equal to 0.9. And then we want 70%, so just times that by 70. That'll give us 70% straight away. Just typing that in on the calculator, and we get 63. And there we go, 63 pounds. Now, of course, you could have just found 10%. 10% of 90 is 9, which would have been a nice way to do it. Even though it's a calculator paper, I do quite like the non-calculator methods. And then just times by 7, and you get 70% is equal to 63. Obviously, that method works really nicely when it's a multiple of 10. However, if it's any other percentage, for example, something like 73%, I do prefer that 1% method, divide by 100 and just times by whatever percentage it is that you're looking for. But there we go, percentage of an amount. So this next question is about powers and roots, but specifically using a calculator. We're not going to know 6 to the power of 5 without a calculator, really. You could take your time and work it out, but for 1 mark, this just wants us to type it in. So 6 to the power of 5 does give us a large number, so you need to use your power button on the calculator. So 6 to the power of 5, or you could obviously write it down in full. 6 times 6 times 6 times 6 times 6, with 5 6s there. And our answer comes out as 7,776. Now we're definitely not going to know the square root of 17.64, so we definitely need to type that into a calculator. So square root of 17.64, my answer actually comes out as a fraction. I can convert that into a decimal. You can write it either way. It doesn't say in the question here that you have to write your answer in a specific form. It just says find the value of, so we're just writing down the number, whether that be a decimal or a fraction. So 4.2 as a decimal, or 21/5 as a fraction. And there we go, that's just about knowing how to use your power and your root button. And obviously not forgetting you could have a cube root as well, so make sure you can find that cube root. It's normally just behind the square root. You normally have to press shift or a coloured button first in order to get that. Just make sure you know where your cube root is. So question 8. So as Drew says, there are more prime numbers between 20 and 30 than there are between 10 and 20. Is Drew right? And you must show how you get your answer. So these sorts of questions, it is wanting us to actually find these and sort of prove it. And this is quite a tricky one because there's quite a lot of prime numbers in between these two categories. Well, in between 20 and 30, remember, 2 is the only even prime number. So all we need to do is sort of go through the odd numbers and just think if they divide by anything. If the answer is no, then it's going to be a prime number. And don't forget you have a calculator. So if you're not sure, for example, 21 is our first odd number. If you're not sure, just try dividing it by, 3, 4, 5. Maybe not the even numbers, but 3, 5, 7 especially. And if they do divide, it's not prime. So 21 divides by 3 and 7. 23 doesn't divide by anything, that's a prime number. 25 does, it divides by 5. 27 divides by 9. But 29 is another prime number. So there's only 2 prime numbers between 20 and 30. Well, what about between 10 and 20? Well, 11 is prime, so that's a good start. We've got quite a few probably here. 13 is also prime. 15 divides by 5. 17 is prime. And 19 is also prime. So we have more prime numbers between 10 and 20. So what did Drew say? Drew said that there are more prime numbers between 20 and 30. Is Drew right? So no, Drew is not correct. There we go. We have our working out there. We don't need to now write a big sentence because there are 4 numbers between 10 and 20 that are prime and only 2 between 20 and 30. We've shown our working out really clearly. You could always label this as primes, okay, but it just says there you must show how you get your answer, and the working out that we've shown there shows that. You can feel free to write something down if it makes you feel a little better. Feel free to write a description there, or just put a star next to it and come back at the end to write something down a little bit more intricate if you feel that you need to. So question 9. It says here is a list of 8 numbers. Caitlin picks at random one of these numbers. On the probability scale below, mark with a cross the probability that Caitlin picks an even number. So even numbers, of course, are the numbers that divide by 2, and the odd numbers are those that don't. So if we look at our list here, how many of them are even numbers? Well, we have the 4 and we have the 8. So 2 out of these 8 numbers are even. And if I write that down to the side, 2 out of 8, I'm going to type that into my calculator because remember you do not need to be able to simplify fractions anymore on the calculator papers because you can just type it in. So 2 over 8 is 1 over 4. I mean, I'd hope that you'd spot that anyway, but 1 over 4 is the probability here of picking an even number. So thinking about the probability scale, we have in between the 0 and the half, and in between the half and the 1, where we have our 1/4 and we would have our 3/4. Now you don't need to label this on, of course, it just asks us to draw the cross. But we're looking for that position, which is around about in the middle of 0 and 1/2. There we go. And there we are, that's where we would put our cross. So there we go. Lots of different probabilities we could be asked to do here. Not forgetting you could also be asked to give words for these. Remember on the left there, 0 is impossible. 1 is absolutely certain. In the middle is an even chance. And then we have situations like this one, where we have words like likely that are used. And then halfway between a half and 1 would be, this is unlikely on the left, and halfway between a half and 1 would be likely. So there we go. It's unlikely that we would pick an even number, as there are only 2 out of 8. It's a lot more likely that we would pick an odd number. Okay, there we go. So there is our probability scale. So our next question says, Olivia recorded the favourite colour of each of the 30 students in her class. The incomplete table shows some information about her results. So we have 4 of them that are completed, and we have this other section down the bottom which is incomplete. Part A says, complete the table for Olivia's results. Well, in order to figure out the missing number, we need to know how many are in these 4 boxes here, so we need to add those together. So if we add them up, and again I'm just going to use a calculator, I don't feel like that's necessarily something I need to write down, because I'm going to write down the total. After I've typed it in, I'm going to make sure it's correct on my calculator. So that adds up to 28. So there's a total of 28 there. It does say in the question there are 30 students, so I might want to write down 30 minus 28 just in case I make a mistake here, but I'm hoping I'm not going to make a mistake with that. We get the answer 2. So there we go, that's the completed table. For part B, it says what is the modal colour. So the modal colour is the most common, it's the mode. So that's just a different word for mode when we are looking in tables. So here, if we want the modal colour, let's have a look. Which one is the most common? Well, there's 10 students that liked blue the most, so the modal colour is going to be blue. And there we go, that'll be our final answer, blue. For the next part, it says Mark asked each student in a different class to name their favourite colour. The number of students who said blue is 3 times the number of students who said green. Write down the ratio of the number of students who said blue to the number of students who said green. Now this is only just a quick question here. We're writing the ratio blue to green. And it says that those who said blue is 3 times the number who said green. So the easiest way to go about this would be to pick any number for green and just times it by 3 to get how many said blue. Now the easiest number to pick would be to go with 1, as we just need to multiply it by 3. It just means blue becomes 3. And there we go, our ratio is 3 to 1. And that language is quite common language in some of the trickier questions too, where it says something is 3 times the size of the other in terms of maybe an angle or a distance, and knowing that that is the ratio 3 to 1. So there we go, 1 being 3 times the size of the other is the ratio 3 to 1, just making sure those numbers are in the correct positions there. On to our next one. So in this question, we have some coordinates. So it says here, write down the coordinate of part A, of point A. So for the coordinates of point A, which is just here, we have our x coordinate just above, -2, so -2, and our y coordinate just to the side, -1. There we go, so both negative there, just making sure we do that x value first, or the along the corridor up and down the stairs. So going across first, across the x-axis, and then we have our y-axis on the second. On the grid, mark with a cross the point with the coordinates -4, 3, and label that B. So -4, so first of all, we'll go across to -4, which is just here, and then up to 3, which is just here. So there we go, I'll mark that with a cross. It's said to label it B, so I'll put a B next to that one. Next one. On the grid, draw the line with equation x is equal to 3. We could have any type of equation here. We could have an x equals or y equals, and they could be negative as well. So this one is x is equal to +3. So all we do is we look for the x-axis, which is here, of course, it's labelled. We find 3, which is just here, and we draw a line through that number. Now, if you're unsure, we would not draw a line horizontally here, because that's called the x-axis. We want the line x equals 3. So the line x equals 3 is just a straight line that passes through x equals 3 and no other x coordinate. So there we go, I'm going to label that x equals 3. These line equations do sometimes throw people a little bit because the x-axis is horizontal, but these x equals lines are vertical. So it seems like it doesn't quite match up to the x-axis. But these x equals lines are just lines which shoot through the x-axis. So it's a vertical line that shoots through 3 on that horizontal axis. So don't think there's necessarily a link between the direction they should be pointing just because one has an x in and one has a y in. But there we go, you could have different lines. You could have, and it didn't ask for this one, but it might have said something like draw the line y is equal to -3. Well, -3 on the y-axis is here, and we would shoot a line through like this, and that would be y is equal to -3. So lots of different lines that you could have. Obviously, don't draw extra lines on your exam question, but there we go, x is equal to 3. Nice vertical line going through 3. There we go, we labelled that coordinate. So question 12, there are 19.5 litres of water in a water container. A cup holds 210 millilitres of water. How many cups can be completely filled using the water in the water container? That word there is really important, completely filled. So it's right to the top. So not just a little bit full, we're looking for it to be completely full, which means we might have some leftover water, but that's fine. So this is about conversions as well. We have our first one, 19.5 litres, and a cup holds 210 millilitres. So we need to know that there are 1,000 millilitres in 1 litre. So 19.5 litres, if we want to turn that into millilitres, we need to times that by 1,000. So we'll do it on the calculator, 19.5 times 1,000, and that comes out as 19,500 millilitres. Now, if we want to know how many cups, or these 210 millilitre cups, fit into that, we just need to divide that by 210. So if I divide this by 210, which you can write as a division or a fraction like I'm writing here, and then we just need to type that into the calculator. So divided by 210, I get quite a horrible number here. I get 92.8 with a dot, 57142 and another dot. There we go. The fact that we have a horrible recurring number there doesn't really matter, because what we have found out is that we don't quite fill the 93rd cup. We fill the 92nd cup, so we can fill 92, so we can put that answer down straight away, but there is going to be some water left over. So there we go, we would round it down here purely because it asks how many can be completely filled. But there we go, 92 cups can be completely filled. On to question 13, it says here the length of a rectangle is twice as long as the width of the rectangle. The area of the rectangle is 32 centimetres squared. Draw the rectangle on the centimetre grid. So if we have a rectangle, the area of a rectangle is length times width. And it has to be two numbers that multiply to make 32. So a nice one that stands out to me, not the right answer here, but 2 and 16, for example. Well, 2 times 16 is 32. That gives us an area of 32, but the length there is 8 times as big as the width. So it's not twice as long. So I need to find pairs of numbers that multiply to make 32, where one is double the size of the other. I can do that by writing down the factor pairs of 32. So 1 and 32, that doesn't work. 2 and 16, that doesn't work. 3 doesn't go into 32. 4 does. 4 goes in 8 times. And actually, straight away, look, 8 is twice as long as 4. So the width would be 4 and the length would be 8. Not sure if there's any others. 5 doesn't go into 32, 6 doesn't go into 32, and neither does 7. So there's no more factor pairs there that we could even test, so it has to be the 4 and the 8. So I need to draw that on this grid. I need to just have a look and check out the size of the grid, make sure it's going to fit. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 along, so I can draw it sideways. You can draw it vertically as well if it fits. There are 8 there, but you'll be going right to the edge of the box. So I'm going to draw 4 down for the width, and then 1, 2, 3, 4, 5, 6, 7, 8 along for the length, obviously using a ruler and a pencil for this. There we go, and joining that all together, and there is my rectangle. And just be really careful, make sure you do draw it really neatly. Even I'm noticing just on mine, obviously I can't do it with a ruler on here, but even I'm noticing I've sort of missed part of the line there. So do just rub it out and be extra careful with these drawings. You do want them to be absolutely perfect. So I might even just go back in, see if I can draw it. There we go, it doesn't seem to want to, it's connecting up to the top there. But you're getting the point, okay? Just make sure it's super accurate when you're doing these drawings. Question 14. So we have a little bit of algebra, lots of different types here. So part A, we have one of our index laws where we have brackets involved. Now when there are brackets involved, all you actually have to do is times the powers here. That is a little bit of a trick because m to the power of 3 to the power of 4 does mean that it's m to the power of 3 times m to the power of 3 times m to the power of 3 times another m to the power of 3. And hopefully you know when you are multiplying you add the powers. So 3 plus 3 plus 3 plus 3, which gives us 12. Now it just so happens that actually we can just multiply 3 by 4 because there are 4 of them. It's the same as adding it up 4 times. So when we multiply them, we do get m to the power of 12. But there we go, just another little thing that you sort of have to remember. So just remember back to when you are multiplying, you add the powers. It could just sort of help with remembering that little trick that we are applying with the brackets. Part B asks us to factorise. It's a good factorise question here because there's no number that comes out of the bracket. But if there's no number that comes out of the bracket here and we've been asked to factorise, there has to be something that comes out. And in this case, there is a letter in both of these parts. So I can put an x outside the bracket. So I'll put an x on the outside and then just think to myself, what would I have to multiply by to get to x squared? That would need another x, and I'll keep the symbol the same. And then what do we have to multiply x by to get 8x? Well, that's just 8. And there we go, closing the bracket. Not forgetting, you might have numerical ones, things like 8x plus 20, something like that, where you've got to spot the numbers that go in, and being careful if it says the words fully factorise, you might have to take out more than one thing. But here, for something like 8x plus 20, well, they both divide by 4, and then you would have 2x to get to 8x plus 5 to get to 20. And then you've also got that scenario where sometimes you have to take a number and a letter out. So lots of different types of factorising that you can have a think about there. Part C says to make v the subject of this formula, and we have t is equal to 4v plus 3. To make v the subject, we want it to be v on its own, whether that says v equals or equals v. It doesn't matter which way around, as the v is on the right, probably easier for us to have it saying equals v. Now to get there, we've got two things in the way. We've got this plus 3 in the way, and we've got this 4 attached to that v. Now, I always leave whatever's attached to the letter right to my very last step. So the first thing I need to do is get rid of this 3, doing the inverse. So taking away 3 from both sides, we would have t minus 3 is now only equal to 4v, as when we take away that 3, this 3 just disappears. So now we have one more thing to do, and that's to get rid of this 4, and we do that by dividing by 4. And when we divide by 4, it creates a fraction over here on the left, and these 4's disappear. So we have t minus 3 all over 4 is equal to v. Your dotted line might say v equals. If it does, you only need to write the next part. If it doesn't, you need to write down the whole thing. But v is equal to t minus 3 all over 4. And there we go, there is some changing the subject. On to question 15. Now in this question here, whatever type of graph, if you get a graph and you have a quadratic, a cubic or a reciprocal, you can use table mode for this. So when you are using table mode, which I'm going to use, you can press, it's normally menu, and then there's a button that says table, or you have to press 3 on most calculators, and that'll open up table mode. And I've got a video where I'm going through some of the calculator tricks, and I will post that in the description so you can check that video out and watch a good walkthrough of how I use table mode to complete these sorts of questions. If you don't use table mode, or you don't have a calculator that allows you to, then you do need to substitute each number in. So to get this number just here, I'm only going to do this for number 3. You can watch the video for this one in the description if you want to, but you've got 3 squared, take away 3, take away 6. And it won't take you too long to type those in, but I just, at the moment, definitely prefer using table mode. So I'm just going to type in x squared minus x minus 6. Then my starting number is negative 3. My end number is positive 3. And it goes up in steps of 1s. So I get in my table for negative 3, 6 in the table on the calculator, so I know I've typed it incorrectly. Then I get a 0, then I get a negative 4, then negative 6 again, negative 4 again, and then 0. And there we go, that's my table completed. Calculator's just done it all for me. Now I need to plot the points. So it says on the grid, draw the graph, and we've got the same equation there. For x values from negative 3 to 3, so we are plotting the whole graph. And if we scroll down then, we have negative 3 that has to go to 6, So that's going to be here. We have -2 on 0, and that's here. -1 was down at -4. 0 was down at -6. Then we had another -6, another -4, and then another 0. And there we go. So that is the graph there that we are needing to draw. So we need to connect this together. We need to use nice smooth lines when we connect it. There we go. So we're going to do a nice smooth curve up to that point. And we're going to come down and continue a nice smooth curve. And it should make a nice U shape. There we go. All the way to the top. And there we are. So the important part here when you are plotting this curve is to make sure that it goes through each of those points. And in this case, it's gone through all the points there. So the next part, we just need to have a look and see if there's any other part to the question. For this one, there's not. So there we go. We've connected it up. We have all of the points joined up with a nice smooth curve, not using a ruler. And there we are. There is our quadratic curve. Okay, on to our next question. So it says here is the charge at a car park in France, and the car park is 0.024 euros per minute. Matas parked his car in this car park. Matas drove into the car park at 10:45. When he drove out of the car park, he had to pay €8.40. At what time did Matas drive out of the car park? So let's have a look at this one then. So if he had to pay €8.40, and this was the cost per minute, we can work out how many minutes he had to stay. So to do that, we would take our €8.40 and essentially see how many of these 0.024s actually fit into that. So we're going to divide by 0.024. So we need to come out of table mode, which we were in from our previous question. 8.4 divided by 0.024 comes out as 350. That's good, a relatively nice amount of minutes there. We just need to convert that into a time, into an amount of hours and minutes, and then have a look at adding that onto that, or taking that away from the 10:45, because that's when you drove into the car park. So we're going to be adding it on because we're looking at when you drove out of the car park. So for 350 minutes, there are a couple of ways that you could convert this. You could go up in multiples of 60 until you get close and add it on, or you could just divide by 60. Now, if you divide by 60 on your calculator, which might be your initial approach, you get quite a horrible number. You get 5.83 recurring. So you can press the button on your calculator, which converts that into a time. Typically, that button looks like this. If I try and attempt to do a relatively bad drawing of it, it kind of looks like that. There we go. I'm not drawing that very well, but there's a little button that looks like this, which will convert hours into minutes. So if I press that button, it comes out as, it looks like this, 5, what looks like degrees. It's not, I'll just talk you through. There you go, it looks like this. So on your calculator, this is the hours, so it's 5 hours. This here is the minutes, so 50 minutes. And this number here at the end is the seconds. So this only works when you're writing hours as minutes, but there we go, we know it's 5 hours and 50 minutes. That was one method of doing it. You could have just counted up in 60s, so we could have gone, well, 60 minutes in the first hour, then 120, 180, 240, 300. So you see there we get to 5 hours, and then from 300 to 350, we have that extra 50 minutes. Completely up to you. There might be different circumstances where using one method over the other is better. Here, they're probably about the same. But 5 hours and 50 minutes. So we need to now add that on to the 10:45. So from 10:45, when I'm going up in time, typically I will first add the hours. So if I add 5 hours to that, well, 2 hours gets us to 12. So it'll go to 3. Doesn't say necessarily it has to be in a certain time format here, but 3 o'clock would be 15:45. There we go. And then we need to add the 50 minutes on. So if I'm going to add 50 minutes on, again, there might be different methods that you prefer to this, but I'm going to first add the 15 minutes, which gets me to 4 o'clock. And then I need to add another, and of course you've got a calculator here, so we know we're adding 50 minutes. I can just do 50, take away 15 on my calculator just to make sure I'm right. Now I'm going to add another 35 minutes. I kind of always like to go to the hour first. So 16:35 would be my final answer. But just trying to break that down in a way that just helps you to add that time on. Because 5 hours and 50 minutes is quite a complex one to add on to 10:45. Another thing you could do, you could add 6 hours and then just take away 10 minutes. For those of you that are happy with sort of adding and subtracting time, that might be your fastest approach. But there you go, 16:35 is the time that he left the car park. And of course you could write that in as 4:35 PM as well. Completely up to you how you write the time there. It doesn't specify it has to be written in a certain format. But there we go, there was some dealing with time. Our next question is looking at scale. So it says here the length of a plane is 19.2 metres. Morgan buys a scale model of the plane and the scale of the model is 1 to 24. Now we already met a ratio like this earlier in the paper. 1 to 24 means one is 24 times the size of the other. So here the scale is 24 times smaller and the real thing is 19.2 metres. So it wants to know the length of the scale model, the smaller version, and it wants the answer in centimetres. So again, we've got some more unit conversions here. We might want to convert this into centimetres. So there are 100 centimetres in every metre. So we need to times this by 100, which would be 1920 centimetres. So 1,920 centimetres. If we want to go down to the model, then we would want to divide that by 24, as we are going down to that smaller version. So divide by 24. We'll type this in on the calculator. So 1920 divided by 24, and that comes out as 80. And there we go. And there is our answer. So straight away, we've got our answer, 80 centimetres. Now you could have divided it first. It might be that you just did 19.2 divided by 24. That comes out as 0.8, but that would still be in metres. So you'd have to times that by 100 still to make sure that it's in centimetres. So just reading the question really carefully there, because it does specify it wants our answer in centimetres and gives us a nice reminder on this one, on the dotted line there, to make sure it is in centimetres. But there you go, there is using a scale, typically relatively nice, especially when it's written in this 1 to something form. It just means one is, in this case, 24 times bigger or smaller, depending on which way we're going. From here, we went from the real plane down to the scale model. Okay, question 18. 60 people were asked if they prefer to text or email their friends, and then we've got some information that wants us to complete a frequency tree. So we're just going to go through each line, make sure that information is in the tree. So the first one says 60, that's already given to us, so I don't need to worry about that line, but always check that first line. 38 of the people are women and the rest are men. Well, if we put 38 then into the women section, and the men there is going to be whatever makes that add up to 60. So you can write your working out to the side for these, but 60 minus 38, as we're using a calculator, I'm not going to write them down for all of them, but 60 minus 38 gives us 22. So there are 22 men. And we'll tick that off. 15 of the men prefer to email their friends. So up here for the men, 15 prefer to email. And that leaves us with 7 that prefer to text. And they now add up to 22. So we've got 2 bits of information there from that 15 men who prefer to email. And then we go tick that off. It now says 60% of the people prefer to text their friends. So 60% prefer to text. Now it says of the people, it doesn't say of the men or of the women, even though we're now on the sort of women section down here. It says 60% of the people. So here we actually need to do a percentage of 60. So up to you how you do that. I'm just going to do 10%. I think this is quite a nice one. 10% of 60 is 6 people. 60% will be 36 people. So let's just check that again. They prefer to text. So 36 people prefer to text. That includes the men over here. So these 2 circles have to add up to 36, not 63. 36. We already have 7 men that prefer to text. So 36, take away 7, gives us 29. So there we go, 29 women that prefer to text. That gives us that 36 in total, we can now complete the amount of women that prefer to email, and that would be an additional 9. 29 plus 9 would give us that 38. So everything's in place. That's all the information we were given. We've completed the frequency tree with a little bit of percentages in there as well. And again, not forgetting that calculator method for percentages as well. We could have worked out 1% and then gone straight to 60. It says here, one of these people is picked at random. Find the probability that this person is a female who prefers to text. Again, it says one of these people is picked. It doesn't specify it's from the men or the women. So it's out of 60. So straight away, before we even have a look at the number, we know it's out of 60 people. To find the probability, this person is a female who prefers to text. Well, there we go. There are the females who prefer to text. That is 29 out of 60. There we go. So 29 out of 60. And there we are. There's our final answer. And there we go. There's some probability from a frequency tree. Okay, so on to question 19. We have some direct proportion. It says here there are 24 grams of carbohydrates in 100 grams of banana, and there are 5 grams of carbohydrates in 100 grams of yogurt. Javier has 60 grams of banana and 150 grams of yogurt for breakfast. Work out the total number of carbohydrates in this breakfast. So we just want to break this down to 1 gram. There might be easier ways, but we want to get from 100 grams of banana to 60 grams, and we want to get from 150 grams of yogurt from 100 grams. So from 100 grams to 150 grams. So if we write this down, we have 24 grams of, and let's just, in fact, if I put this into a table, because they're both grams, I'm going to get a little bit confused here. So I'm going to write this as carbs, and I'm going to write this as banana. There we go. Now we want to get from 100 grams of banana to 60 grams of banana. It doesn't matter how we get there, but typically if we have a calculator, we can always divide down to 1 gram. And that's going to be really nice and easy to do. We just divide by 100 and then times by 60. And I'm just going to do exactly the same to the other side on a calculator. So 24 divided by 100 gives us 0.24, which of course we probably know even without a calculator, divided by 100, and then timesing by 60. This one I definitely don't know without a calculator, but times 60, and that gives me 14.4 grams. So there we go. In my 60 grams of banana, I have 14.4 grams of carbohydrates. I need to do exactly the same with the yogurt. So I'm going to do exactly the same over here. You don't necessarily have to draw this into a table, but I do think it looks really visually quite nice whenever I'm dealing with anything which is in direct proportion. So for this one, we have 150 grams of yogurt that we're trying to get to. So I need to put that down the bottom as we don't have any information for that. So 150 grams of yogurt down here. There we go. And we were told that there are 5 grams of carbohydrates in every 100 grams of yogurt. Now again, I'm just going to go down to 1 gram. There's actually a quicker way I think here because it's from 100 to 150, which is just 50% more. So I could use a multiplier and do something like multiplying by 1.5 or something like that. But I'm just going to stick to this going down to 1, as it just follows the same method that's going to work for anything, even though 100 to 150 is quite a nice one. So divide by 100 times by 150. So 5 divided by 100, and you can do this all in one go. You don't necessarily have to write it all down, but 0.05 times 150, and that gets me 7.5 grams. So there we go. In total, I need to add these together. So I have my 14.4 from the banana and the 7.5 from the yogurt. I'm just going to add those up on my calculator, and I get 21.9, and there we go. There's my final answer, 21.9 grams. And there we go. Now, it seems like quite a lot of working out there for 3 marks, but actually, it's only because I've drawn the tables and I've written down every single step in between. If you were happy with this, you could sort of type that in one go, 24, and just press divide by 100 times 60, write down the number. The same with the carbs, divide by 100 times by 150, write down the number, and then all of a sudden it seems like not very much working out at all. But as I've written everything down and kept it very visual, it does look like a lot more working out than we've necessarily sort of maybe had to do. But there we go. A bit of direct proportion, 21.9 grams. Okay, so we have a little bit more algebra again. We've got an equation here, 10m minus 30 is equal to 40. Little equations like this could be written in brackets as well. I'm just looking at the 10 and the 30 and thinking that could have been written as 10 lots of m minus 3 is equal to 40. So if it is, and you do have something in brackets, just remember to expand those brackets first. But there we go, this one doesn't have any brackets. So straight away we can add 30 to both sides of this equation, which gets us 10m is equal to 70. And then dividing by 10 to find the value of 1m, m is equal to 7. And there we go, m equals 7, final answer, a nice little equation. Part B here, we are asked to write an expression. It says there are X sweets in a box and Y sweets in a packet. Write an expression in terms of X and Y for the total number of sweets in 3 boxes and 2 packets. Now, they're not trying to trick you here, not trying to catch you out. It's 3 boxes and a box is X. So we just write 3X. And there we go, that's half of our expression done. For the next one, 2 packets and packets are Y. We're adding them together as we're getting the total, so plus 2y. And there we are, there's our expression. It might say something like write a formula for the total, and it might say where the total is t or something like that. So if it did say something like that, where it says the total is equal to t or something, and it asks you to write a formula, well, you might write this as t equals 3x plus 2y. The total equals 3 lots of x plus 2 lots of y. But there we go, it asks for an expression, which doesn't have an equal sign in. So it is just 3x plus 2y, and that is an expression to work out the total. If we had 10 boxes, we'd do 3 times 10, that would be 30 sweets in total there. And then if you had something like 2 packets, you'd do 2 times 2, which is 4, and add them together, and we'd have the total amount of sweets. So there we go, there is writing an expression. Now this next question, we have some percentage profit. It says Cody buys a pack of 24 pens. The pens cost £11.28. Cody sells all 24 pens for 50p. Work out Cody's percentage profit, and it says give your answer correct to 1 decimal place. So we know we're going to get decimals involved here, so we need to just be really careful in that final stage. Now, in order to work out the percentage profit, we actually need to work out the profit, which is how much money he's actually made after he sold them all, considering he paid £11.28. So we need to work out how much he's actually sold them for. Now, if he sold them all for 50p, well, we need to do 24 times 50p. However, this is in pounds up here, so unless I want to convert that to pence, in fact, what I'm going to do is just convert the 50p to pounds, which is 0.5 or 0.50, if you prefer to write it like that. I'm just going to type in 24 times 0.5, which gives us a nice amount that comes out as £12. So he sold them all for £12. He paid £11.28. So to work out his profit, we'll take the £12 he sold them for, subtract the £11.28 that he paid for them, and just do that on the calculator, and that comes out as 0.72, which again is in pounds, or you could write that as 72 pence. So that's the profit that he made in pounds or pence. We need to write it as a percentage of what he paid. So for percentage profit, we would write the profit, or the change, you could call it, over the original, as it's not always about profit. It could be the percentage increase or decrease or a loss. But it's the profit over the original, and then we'll times by 100. It's a similar process to what you would do if you've ever given yourself a score in a test. If you scored, let's say, 16 out of 20, you can write your answer as a fraction, but if you type it into your calculator and times by 100, it turns that into a percentage for you. We're using exactly the same process here. So if I type this into my calculator, I have 0.72 over the £11.28, the original price that you paid, and I'm going to times it straight away by 100. So 0.72 on the top, £11.28 on the bottom. I'm going to times straight away by 100. There you go, and I do get quite a long decimal here. So 6.3829. I'm not going to write them all because it only wants my answer to 1 decimal place, which is just here after that 3. So after the line, it's an 8, so it is going to round that up. It's going to be 6.4, and that is a percentage and that is his percentage profit. So there we go, that's my final answer, 6.4%. We've already got that percentage sign, so I don't need to write it again, 6.4. Okay, next question. We've got some standard form conversions. Now this one here, we need to move the decimal, so it's between 1 and 10. So I want this to be 3 point, and then any up to the last whole number, so 4 and 6, so 246. And standard form is just written times 10 to the power of however many jumps, positive for a number that's bigger than 1 like this, and negative if it's 0 point number. But we'll figure this out after we've done it. So 1, 2, 3, 4, 5, 6, 7 jumps. So 3.246 times 10 to the power of 7. And there we go, it is a large number, so we definitely have a positive power there. 3.246 times 10 to the 7. Now this next question is asking us to convert it back the other way. This one does have a negative power in. So a negative power is a 0 point number. Now when I'm doing these, I first write down those whole number digits without the decimal. I sort of hover my pen where the decimal was, so it was just here. I'm going to hover it just above, because I'm going to do those little loops. I need to jump to the left. If I was to jump to the right 3 jumps, it'd go 4,960. And we know it's a 0 point number. So 1, 2, 3, that's where the decimal's jumping to. And then I'm just going to fill under there with zeros and tidy it up at the start with a 0, and then rewrite that really nice and clearly on my dotted line. So 0.00496. And there we go. There's a standard form conversion. Okay, on to our next question. So this question here is asking us to look at the highest common factor and the lowest common multiple of these two numbers, but the numbers are given to us in prime factor form. So to find the highest common factor or the lowest common multiple is a really nice method for this. We just need to write these prime factors out in sort of long form so we can see what it looks like. So in A we have 2 times 2 times, there's quite a lot of 3s here, 3 4 times, and then a 7. For B, a much smaller number, which is 3 times 3 times 7 times 7, smaller in terms of the factors that we have there. We've only got 4 numbers to write down rather than all of those. Now for the highest common factor, all we have to do is identify which prime factors are in both numbers and if there are any duplicates. Now I like to either underline them or highlight them, but here we have a 3 in both, another 3 in both, and there is 1 7 in both. Now whatever is in both, so 3, 3 and 7, all we do is multiply those 3 numbers together. So 3 times 3 times 7, we can type it in on the calculator, 3 times 3 times 7, and that comes out as 63, and that is our highest common factor. So there we go, 63 is our final answer. Now the lowest common multiple is a little bit more complicated. I mean, if you've practiced these, and obviously sort of when I go through these with people and they've got the hang of them, they do them very, very quickly. But it might be that this could be the first time you're seeing it. If it is, it's a relatively complex sort of process to look for the first time without a huge amount of explanation. But if you follow along with, then you will hopefully see this is a relatively nice process. Now again, what we're going to do is highlight what's in both. So there's a 3 in both, there is another 3 in both, and a 7 in both. Now to find the lowest common multiple, what we do is we first multiply, and this is how I do it, first multiply like we did before, those 3 numbers there that are in both. So 3 times 7, that would obviously give us the highest common factor. So to find the lowest common multiple, we also have to multiply by every other number there that's not highlighted. So 2, 2, 3, 3, and the 7. We just don't ever, in either of these scenarios, use the doubled up versions that we've highlighted in both. So if I add all the remaining numbers in, 2 times 2 times 3 times 3 times 7. Now this one here is a particularly horrible one because we are going to get a very large number here, but I'm going to type it in, 3 times 3 times 7 times 2 times 2 times 3 times 3 times 7. And I get a very large number, 15,876. And there we go, that's my final answer, 15,876. 876. I'm just going to have another look at my calculator and just make sure I've definitely typed all the numbers in. I've not doubled it any up, so I've got 3 times 3 times 7 times 2 times 2 times 3 times 3 times 7. I'm happy with my answer there. But there we go. There is a method for finding the highest common factor and the lowest common multiple using these prime factor numbers. And there we go. On to our next question. So for this one, we first have working out an estimate for the mean height of these children. It does tell us in the question that there are 80 children. So when I have mean from a table, we have to multiply across. However, in a grouped frequency table like this, we need to use the midpoints. So here the midpoint of 130 and 140 is 135. We then have 145, 155, 165 and 175. So we're going to get some quite big numbers here, but that's fine because we're doing it on a calculator. So 4 times 135 is 540. So do make sure you write these down really clearly because we're going to have to add them all up in a little second. So 1595. 155 times 24 is 3,720. 165 times 22 is 3,630. And then 175 times 19, and that comes out as 3,325. So we need to add all of these together. So plus 3630, and this is one of those times here where you just need to be really careful typing all these numbers in. Don't rush them, just make sure you add them all up correctly. Otherwise, it's very easy just to miss a button or miss a number and get the whole thing wrong. So there we go, 12,810. So that's the total here, height or estimated height of all these 80 children. We can't say it's their total height because we don't know what their heights are in these little categories. We've used the number 135 here, but for all we know, they could all be 131. We just don't know, so we are using an estimated amount. So to get the mean, we now take that estimated total and we're going to divide by 80. I'm just going to type that in on the calculator, dividing by 80. And there we go. So I have got a decimal for this. It came out as 160.125. So not an awful decimal there, but we would write down all the decimals for that one unless it asked us to give our answer to a certain amount of decimal places. But there we go. There is our estimated mean for the height of these children. Part B asks us to draw a frequency polygon. So a frequency polygon, nicest possible graph we could be asked to draw really, especially now we've already plotted the midpoints. I just need to plot them on using the midpoint and that height and just being careful. I read the scale very carefully. So 135 goes up to 4. There we are, each square is 1, which made this one really nice. 145 goes up to 11. So just above the 10 there. We have 24, 22 and 19, let's see if I can remember them. 24, 22, it's quite hard to see the middle. So if you need to use your ruler just to line it up and make sure it's in the right place, definitely would recommend that. And 19, that was the last one, wasn't it? So 24, 22 and 19, perfect. Okay, so frequency polygon, we're just going to do a dot to dot, straight line, ruler, nice and clear, dot to dot from the start to the finish. And there we go, making sure we hit every point. And there we go, there's your frequency polygon. Definitely not using a smooth line, definitely not joining it up to the axes or anything like that, and making sure we plot them on the midpoints. And there we go, hopefully nice marks there for a frequency polygon. Okay, our next question, we have a prism, a triangular faced prism. It says the cross section of the prism is a right angled triangle. Hopefully you can see that. The cross section is this part of the shape that goes all the way through. And to get the volume of a prism, you get the area of that cross section and times it by the length that it goes through. So in this case, 25. So this question here says the base of the triangle has a length of 5. Cool, we can see that. The prism has a length of 25. And then it says the prism has a volume of 750 centimetre cubed to work out the height of the prism. So we want to know the height of it, which is this length on the triangle here. So that's what we're trying to work out. Now, I did actually just mention that in order to get the volume, you take the area of the cross section, you times it by the length, which is 25, and it gives you the volume. So in this case here, if we want the area of the cross-section, well, the area, if I write the area of the cross-section, could write this as a sort of an equation as well, but this is the formula, area of the cross-section times the length, which is 25, and that now equals 750, which we've been told in the question, so a bit of reverse volume. Well, if we want to know what the area of the cross-section is, we would do 750, divide by 25, and there we go, that tells us it must be 30. So divide by 25 here, there we are, we get that the area equals 30. There we go, that'll now be in centimetres squared. We don't necessarily need to write the units with this, we're just interested in that number 30. It says work out the height of the prism. Now looking at that triangle there, which has a base of 5, I would imagine that some people would look at that and go, oh, well, yeah, well, that's great. Well, that's going to be 6 then, because 5 times 6 is 30. However, we need to make sure we don't forget our area of a triangle formula here, which is base times height, and then we divide it by 2. So if the height was 6, which it's not, 6 times 5 is 30, but you would divide that by 2, which would give you an area of 15. And our area is 30, so we know that that's incorrect. So spotting the number that is wrong can help to very quickly find that number that's right. Because if the height was 6, which gives us 30 when we do 6 times 5, but the fact we're halving it, we just need to double that number. So actually it's 12 rather than 6. 12 times 5 is 60. Divide that by 2 is 30. That's just a little method that I quite like, using that wrong one to actually help me get the right one very quickly. So the height would be 30. Now if you don't use that method, you could of course write down the base times height divided by 2 equals 30 and use it as a bit of a formula. Well, the base is 5, the height we don't know, so it's 5 times the height divided by 2 equals 30. I much prefer the method I've just sort of talked about, but here we can now times by 2, so 5 times the height equals 60, and then dividing by 5, the height equals 12. So that's sort of your, I guess, algebraic way of writing it down. That's fine as well. I do like that method. Okay, if you prefer that, please stick with it. But there we go. There is the height, 12 centimetres. But there's different ways that you can sort of think about that question. And there we go. Our answer is 12. Question 26. We have some angles in polygons. This one here says, show that polygon P is a hexagon. That word show that is really important. And it says you must show your working. So paying really close attention to the language here, we need to write down absolutely everything that we do. So to start with, we know in a square the angle, or the interior angle, is 90. Now that's not something that we have to show working for. We are expected to know that a right angle is 90 degrees. In fact, you could just be asked that, what's the size of a right angle? And you say 90. It's just a fact, one of these facts that we have to remember. But polygon P in this 12-sided polygon, we're not supposed to just know the interior angle for that. Now, if we are looking at all these shapes, and if polygon P is a hexagon, then they will, and I'm going to just sort of get rid of this over here, they will all fit around this point like a jigsaw. There'll be no gaps, so that'll add up to 360. So that's another sort of fact that we need to be aware of here. So if we look at the interior angle of this regular 12-sided polygon, regular being important there because it does mean that we can divide the total within that polygon by 12. Well, let's work out the interior angle. So the formula for this is n minus 2, where n is the amount of sides. So we're going to do 12 take away 2, which is 10. We times that by 180, that means it's made of 10 triangles. That comes out as 1,800. And if it's a regular 12-sided polygon, we would divide that by 12 as it's 12-sided. So divide that by 12. We don't have to do any bus stop division or anything like that because we are using a calculator. So 1,800 divided by 12 gives us 150 degrees. So that interior angle there is 150 degrees. So in terms of this as a jigsaw, if we kind of think of it as all these pieces being put together, well, we have this one missing piece now, and that's polygon P. We have the 90 and we have the 150. So what's that missing gap there in polygon P? Well, let's add these together. So 150 plus 90 gives us 240 in total. And as we said, they have to add up to 360. So 360, take away that 240 that we have in the square in the 12-sided polygon, leaves us with 120 degrees. So if that gap there is 120 degrees in polygon P, is that a hexagon? Well, let's just replicate the working that we just did for the 12-sided polygon, but for a 6-sided polygon. So we would do 6 take away 2, which is 4 triangles. So 4 times 180 is 720, and we want to divide that, if it's a hexagon, of course, dividing by 6, and there we go, that gives us 120. So it is a hexagon. It did say show that it's a hexagon, so we did know it was going to work, but this final stage here was me showing that it's a hexagon. I'm not just finding the gap there that's 120, I've actually shown that that matches the same interior angle of a hexagon. So you could write next to that, therefore it must be a hexagon, completely up to you, but the working out there is hopefully really nice and clear. We found the interior angle in the 12-sided polygon, which was 150. We know that they had to all add up to 360, so we found the gap, including the right angle in the square. So the gap was 120, and then we finished it off by looking at the interior angle in a hexagon and matching it up and showing that it's 120. So there we go. That is for a regular polygon. Not forgetting, if you have an irregular polygon that you have to work out, the first part of the working is identical. We just don't do this step here for a regular polygon. So we wouldn't have to divide by 6 because all the angles would be different if it was an irregular polygon. So there we go. That is some angles in polygons. Question 27, we've got some expanding and factorising. So 2 sets of brackets, and you've got to be really careful on this one because there's a subtraction here, which is harder than if they put an addition there. So we have 5 times x, which is 5x. Not forgetting expand just means to multiply, and then plus 20, and when we multiply, it gets rid of the bracket. So that's expanding by 5. The second bracket is getting multiplied by 2. However, as there's a negative there, I like to times these by -2. Otherwise, I need to remember to subtract them after I've expanded. So I much prefer just to times by -2. Likewise, if there's a plus there, we're just timesing by +2, which obviously doesn't really change much, but a negative does. So a subtraction, -2 times x is -2x. And then -2 times -3 will give us +6. So that double negative there, switching the sign. We now just need to simplify these. So I have 5x, take away 2x. In total, that's 3x. And I also have plus 20 plus 6. Well, that's relatively nice, actually. That's just plus 26. And there we go, expanded and simplified. Part B is asking us to factorise. So when factorising, this is a quadratic this time, which means it goes into a double bracket. To find the numbers that goes into those double brackets, we have a look at the 12, write the factor pairs, so 1 and 12, 2 and 6, 3 and 4, and we're looking for the pair that add together to make +7. So nice, relatively nice in this one that we've got there, all positive, but we have 3 and 4, they add to make 7, so x plus 3 and x plus 4, and you can write those in either order as well. So I'm just going to write it as x plus 3 and x plus 4, but they could be written as x plus 4 and x plus 3 as well. And there we go, factorising a quadratic. Question 28 is looking at the volume of a cylinder, but it's asking us later on in the question to work out the mass of this structure here, which is made out of gold, and the density of gold, it tells us, is 19.3 grams per centimetre cubed. That says give you answer to 3 significant figures. So as it's mentioned density, straight away I'm going to write down my density formula. So you can either write down density is equal to mass over volume, or if you use a formula triangle, you can write it down as a formula triangle as well. So we can write density is equal to mass divided by volume. Density, mass, and volume. Now this question wants us to work out the mass. So straight away, to work out the mass, we do density multiplied by volume. So I just need to actually get the volume, otherwise I'm not going to be able to get the mass. I've got the density, so I know I just need to do 19.3 multiplied by whatever that volume is. So let's have a look and see if we can work that out. So here we have a cylinder. Now to get the volume of any prism, which we have already discussed, you get the area of the cross section, which in this case is this circle, and times it by the length that it goes through the shape, which in this case is this 43. So we need to know how to get the area of a circle. The area of a circle is pi r squared, not to be confused when you're finding the circumference, which is pi times diameter, or pi times 2 radius. So we are using our area formula. So for the area, we're going to do pi times 15 squared. Now when we are finding the volume, we've already said we need to multiply that by the height. So it's pi r squared times by the height, and that's going to give us the volume. So the height here is 43, so pi times 15 squared times 43, we can do that all in one step. Let's see what we get. Pi times 15 squared times 43. And we have a volume here, which is going to give us a very large number, I'd imagine, when we get the mass. So 30,394.90892. Now, I don't really even want to write that down again, let alone type it back in my calculator. So I'm going to make sure I leave that number on the calculator. There is actually a version in terms of pi, which you could write down as well. That's absolutely fine to do. But I know I need to do that now as my volume. So it's 19.3, which was the density, multiplied by 30,394.90892. So I'm just going to press times 19.3, so I don't have to type it all back in again. And there we go. That gives us my final mass here now, which has come out as 586,621.7422. And let's just separate that with a little comma there so I can see that number properly. So 586,621. It says give your answer correct to 3 significant figures. So 3 significant figures, I want to chop it here after my third number. So 386. So it's either going to be 586,000 or 587,000. After the line we have a 6, so it is going to round that up as it's closer to 587,000. So that is 587,000 grams. And there we go. That is the mass of the structure. Okay, on to our next question. So it says here, Connor invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Connor will get at the end of 4 years. Now, there are 2 ways to approach this. Obviously, a non-calculator approach or a calculator approach. We want to use the calculator approach, but within that, we have sort of 2 methods in terms of how we type it in on the calculator. So with 1.5%, you need to either be aware or know how to convert that into a multiplier, or you can actually use your percentage button on the calculator. Now, if we are going up by 1.5% each year, then every year we have 101.5%. Now, you can actually just type that in on your calculator, 101.5%. Or, to turn it into a decimal multiplier, if you type that into your calculator as well, 101.5%, let's just type it in, and press equals, it will convert it for you. So we could write that as 1.015. Now these are your multipliers. So to increase on your calculator by this amount, we just take the £200,000 and multiply it by either one of those. I quite like to just use the 101.5%. Just personal preference, 101.5. That percentage button is normally down the bottom. Mine's behind my answer button, close to the equal sign. I just have to press shift first. There we go. Now, if you type that in, so 101.5%, it will increase it for you. So it's going to add on that extra 1.5%. However, in this question, it says we're going to need to do this for 4 years. So we have to do it 4 times. So when you have that, you just need to add that as a power, so a power of 4. If we type that into our calculator, we'll get our final answer. So there are, of course, 2 ways that you could type this in. You could either type that percentage in, or you can use the multiplier, which you got anyway from typing that percentage in. It doesn't matter which one you type in. And there we go, to the power of 4. Now, which either one of those you type in, as it doesn't actually matter at all. Let's just type in the multiplier, 1.015. There we go, and I get a final answer. It comes out as 212,272.7101. So that's £212,272.71. Now, we don't need to include these numbers at the end here. Our monetary system only goes up to the nearest penny. It doesn't matter if you round it up or down. Typically, they would round down in real life. So for the final part of this question, it does say in the language here to calculate the total amount of interest. So we now know exactly how much Connor will have in the bank, but in order to get that total amount of interest, we are going to have to subtract the original, and you might actually be able to just see the extra amount there, but we need to subtract the original amount, which was the 200,000, and that leaves us with the total amount of interest being £12,272, and as we said, 71 pence. So there we go, that's our final answer, £12,272.71. So just make sure you read the language in the question carefully, particularly where it says about compound or simple interest. Because remember, in simple interest, we would only need to work out what Connor got in the first year, and then we would just multiply that by 4, and that would give us the total. So in the case of simple interest, we'd take the same first approach here, but we wouldn't use the power of 4, we'd just times by 1.015, then we'd figure out how much interest he got, and then just times that by 4. Or of course, you could just work out 1.5% another way and multiply that by 4, but there we go. Always make sure you just read the language of the question carefully. This one here said calculate the total amount of interest. Okay, so on to our next question, where it looks like we're going to be doing some Pythagoras or SOHCAHTOA. It says work out the value of x, which is this side length. In order to use Pythagoras, we need at least 2 side lengths, and we don't, we only have the one, and that's why we're given the angle. So we're given this angle of 53 because we can use trigonometry for this. So it says give your answer correct to 3 significant figures. Well, we'll figure that out at the end. So with SOHCAHTOA, we need to label the sides. So for this one, opposite the angle, we have not been given it and we're not looking for it. So I'm not going to label that one. We have the hypotenuse, which is the longest side, and as that other side there, which we've got the arrow pointing to, is the opposite, this will be the adjacent. So typically, I would now write down my SOHCAHTOA formulas. Whether you write those as ratios, as formulas, or as formula triangles is completely up to you. So for this one, we are using A and H. So that's our cos formula there. We're looking for the A, so we cover up the A, which tells us we need to do a multiplication. So it's cos times H. When you press cos on your calculator, it will open up a bracket, and that's going to remind you you have to put the angle in that bracket, and then make sure you close the bracket. So cos 53, close the bracket, multiplied by the hypotenuse, which is 14.5. So times 14.5, and that comes out as 8.7263. I'm going to stop there because I've written down 5 significant figures, which is enough to now round it to 3 significant figures. So 8.72 after the line, and that's going to be 8.73, as it's a 6 afterwards, and that is in centimetres. However, it just says find the value of x, and it says x centimetres, so I don't actually need to put centimetres with this, I just need to put the 8.73. And there we go, that is the end of this paper. Don't forget that I have the practice booklet linked in the video, going through a lot more than the few topics that were in this paper here. So do make sure you check that one out. I can't emphasise that enough. That particular video has a lot greater depth of questions for you to look at. There are absolutely tons of topics in there, each one being linked to the video lessons for each of them. So do make sure that you check that one out. But otherwise, that is the end of this paper. Hope you enjoyed that, and hopefully the best of luck going into your Paper 2 exam. And I will see you on the next video where we're looking at our Paper 3 questions. Now hopefully you've got your revision under control and you are making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live, weekly, interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3.